Hi, friends. It's Chris here, talking about Agentic AF. That's architectural framework for those of you whose minds are totally in the gutter, but I respect that. Anyway, we're going to be talking about agentic classification and types. Now, this is kind of important. And the reason it is because the way in which you classify agents or categorize them is going to impact the way you do your ideation pipeline as well as you do your adaptive governance. So, this is quite important up front. I'm going to go through some options, right? Like, I don't think there's a single answer to all of this. It depends on your org, your IT department, what people know. I mean, look, there's a lot of ingredients for this recipe, so let's just dig in, and I'll tell you what I know works. Okay, so there's a difference between type and classification. So if you think about like classification or category, that's like, I don't know, you would have a mammal as a category. And those mammals can have different types. So they can have cat, dog, mole, badger, ewok, I don't know, whatever. So that's typically what you're going to have in that layer of categorization, right? Now, what happens with agents is that you might have a bucket of a category that says these are category X, and then you may dig in one layer lower to say these are type Y agents, which is really interesting, right? Because you can have different types associated to different categories depending on certain rules and regulations. Now, I know in a lot of organizations, there's kind of one or two layers to this. I'm going to show you some examples, and then, yeah, you can kind of figure it out for yourself, I guess. So, agent categorization slash classification. So, Microsoft have released some slides. I obviously built on the good work of others. In other words, I stole these. Yes, but they are publicly available. So, hey yo, thanks, Microsoft. So, there are kind of three core categories when Microsoft talk about agents. So you started with what we call retrieval agents, which is cool. So a retrieval agent is effectively an agent that retrieves stuff. I feel like it's in the name. I don't know. The next one is task-based agents, and these are agents that do tasks. Okay, it's probably in the name. Then you have autonomous agents. These are a little bit weird, right? Like autonomous agents act in the background. They do things for you. Um, yeah, it's a bit like my kids, right? And my kids are like little digital demons, well, real life demons. What they do is they're a bit autonomous. They go and get me drinks from the fridge. Normally, it's the wrong drink, but hey, at least the thought's there. But yeah, it's quite important that they operate kind of behind the scenes a lot, which is really cool. And you can break down these categories into varying layers of classification if you want. You don't need to. So you can see retrieval agents. You can break those down into a retriever type agent or advisor type agent, which is a certain type, which we'll get into a little later. You can have task-based agents, you can have collaborators and assistants, and then your autonomous layer, you can have orchestrators and performers. I'm going to pause. All right, so Ted, the developer, who's sitting in his room right now going, but we can have different agents across the different types. And the outlier says, I've built a multi-autonomous agent with that's a collaborator. I'm like, yeah, dude, I get it, right? Like, we're not covering every outlier. If you did that, you'd be here for decades and decades. So sorry, Ted, the dev. By the way, if your name's Ted, I'm also sorry. I don't know. I don't actually know any Teds. I know one Ted actually. Anyway, sorry to the Ted I know. But the point is that you can't cover every outlier. So don't expect to. Okay. So try and think of like groupings in which you can classify these things. Okay. And when you break those down even further, there are a couple of examples. So typically, like a retriever agent finds and delivers relevant information to support a person's task or decision. Yeah, cool. Makes total sense. So I put in a prompt, I get some stuff back. There we go. Retriever agent, job done, check. Advisor agent gives insights slash guidance or recommendations, bit more detailed on the retrieval side. So it's going to actually give you agentic opinions, which are fine, I guess. Depends who's writing the agents. Then you'll have a collaborator, works with people or systems to get things done. Your assistant helps the person complete a task or make a decision. I feel like they're kind of one and the same, really. Then your orchestrator, which coordinates a series of steps across systems or teams, and your performer agent takes direct action, and completes tasks automatically. So a lot of the time, we kind of see performer agents and autonomous orchestrators, sorry, kind of being these facilitators of things that happen, right? Like things that take place. Okay. And this is really where agentic AI is quite special. So retrieval and collaborator, yeah, I kind of feel like we're all there, but when you get to that orchestrator performer mode, that's pretty damn special. Now, I like to look at this a little differently, okay? And the reason I do is because I am a nerd, I am Ted the geek, and I do like looking for holes in scenarios like this. So here's the deal. When looking at this, I took a look at AI agents for beginners, and I loved this breakdown of how agents work. right? Now, I'm sorry for all the text on a slide. I don't feel bad. But they break it down into these kind of 7 or 8 layers, which 7 layers, which I think are really good examples of agentic types. Now, here's the deal: a simple reflex agent can be an autonomous agent, right? Here, that's the thing, right? You've got to figure out your classification slash categorization. Um, so I like this because it is a bit more technical. I might not front this to an organization and say, "Hey, uh, Mary from accounts, you've built yourself a goal-based agent." I don't know. I feel like a retrieval agent might be a bit of a better way to describe it, but I like this from a governance perspective. So anyway, as you kind of break it down, you can see that they've got an agent type, a description, and an example. So as an example, a simple reflex agent performs immediate actions based on predefined rules. As an example, a travel agent interprets the context of a prompt and returns details relevant to that request. So we do a lot of these, right? We build a lot of these inside of Agent Builder and SharePoint. So you can see build an agent to save you time. Fine. Create me an agent that reviews the content from a SharePoint list. I better change the P to a capital P before the delicate SharePointers lose their ever loving minds. I'm so sorry. Please don't cancel me, MVPs. I apologize humbly. I'm okay to receive slanderous mail in my inbox, but I'm sorry for making it a small p. You guys will be okay. You will be okay. Create a SharePoint list that returns information. This information will be related to astrobiology. Sweet. Super straightforward little agent that I want to build. What I'll typically do is generate the agent. That's going to go through the whole process, and it's going to give me a scenario where I can go and create my agent. I can attach my SharePoint slides. So you can see it's giving me instructions over there. That's pretty cool. I can go in and add data if I really want to, or I can go and drop in a URL if I need to. So as an example, what I might do is add in like the SharePoint URL there. But this is a very good example of a retrieval agent, something that gives you information back. What you would do to make this kind of model-based reflex agents, as an example, perform retrieval and advisory actions based on a model of the world and changes that to that model. So now what you would want to do is say, okay, that's effectively knowledge or a knowledge primed model. So you can actually give it a specific set of information. And as that information changes, the information is shared with the user. As an example, that SharePoint list might have files added to it. And that's cool because it's always going to give you the latest information. You will have goal-based agents, which can create plans and achieve specific goals by interpreting goal descriptions. So, as an example, the travel agent selects a journey by determining necessarily travel arrangements. This is a great example, right? So, you're going to put in your travel arrangements and you're going to say, my goal is X. How do I get there? Or how do I achieve this? And the agent will do the kind of hard working in the background, right? But that means you have to have awesome data and you have to have awesome knowledge, right? That's priming that agent. Then we get into the interesting part, and we have these things called utility based agents. Now, this is where things get a little interesting, right? Because utility based agents actually maximize utility based on weighing convenience versus cost versus other variables, okay? And they have action. So these agents perform actual actions. Now, pause. Ted, the creepy developer, I'm sorry again if your name is Ted. What you might find is that utility based agents can cross the streams on goal based model and simple, right? So what you may find is that you might have some agents with very simple actions. It doesn't make them always utility-based agents. Utility-based agents are a little bit more complex, right? Then as we move down, we get to learning agents. Now, this is where the real rubber hits the road, right? So what can happen is you actually give that agent the ability to learn the interaction that you've had. Now, in Microsoft, it's quite cool, right? Because there's a thing in the background called the graph, and this graph provides context. So as an example, when I use Copilot, it kind of knows what I've been doing most recently. So if I've been reading tons of emails and replying to a million emails, it can access the context of what I'm doing. Okay. Super important. Not all agents can do this. Okay. So it is important you have to kind of set that up, right? And that memory is not always out the box. So what a lot of people do is they may have a data set in the background that's storing information that you can recall, normally through a login. There's things called work IQ, which allow you to kind of interact with that kind of specific actionable stuff that lives inside the agents. And then there's the ability to attach memory to that. So there's a lot of ways to provide memory into an agent, but it's not always set up as standard. Okay. So tools like Copilot Studio, when I pop that open and I select an agent over here, what you will find is there's no actual like inbuilt memory. There's nothing that says turn on memory. Okay. And that's because that doesn't necessarily exist directly out the box, but you can access varying layers of the graph inside these agents. So you can actually see I can graph ground this with semantic search. So it's not necessarily memory. Memory comes in different ways, shapes, and forms, but actually it's the ability to recall information somebody has put in previously, okay, and understand the user's interactions. So sometimes that's a data structure in the background. Now, as we get bigger, we look at these hierarchical agents and multi-agent systems. These are cool, right? This is where I think the real interesting stuff happens. And actually, these hierarchical agents are effectively collections of a parent agent with a bunch of children agents. So, like, if you think about this agent with these little digital minions that are running around, you'll have your orchestrator agent in the hierarchy conducting the digital minions to do their evil bidding. Okay. Now, again, it's not always going to be that straightforward. You might have a hierarchical agent with a reflex agent, a model based agent, and a goal agent all doing its evil bidding in the background. Very important. So it's not always going to be one simple agent type. And that's where I think this gets pretty interesting. Then you get what we call an agent mesh or a multi agent system. And this is like a network of agents all working together. So, as an example, if I open up my pub agent over here, you can see my franchise pub onboarding assistant. You can see that I've got a bunch of child agents. So these are the kids. It's a single parent at the moment, so you can see that there's only a single orchestrator. Sorry, you're going to have to get a babysitter for the weekends when you want to go out, orchestrator agent. But what I've also done is I've given it some attachments, right? So you can see I've actually got agents that live outside of this ecosystem, and these are connected agents. So what I've done is I've gone add agent. Okay, I can use tools like Fabric and Foundry agents in Copilot Studio, but actually you can see I've got a ton of connected agents that I can pick, right? So I can select my AI solution ideation assistant agent and attach it into this agentic ecosystem, which is super cool, right? And what that means is that when I start interacting with this orchestrator agent, it no longer becomes a single parent. Oh, okay, that's interesting, right? Because when I go into my AI solution ideation agent, I can do the vice versa attachment. So I can start interacting between the two. Now, that's cool, right? Because you can do all sorts of fun things with that, but that does promote some weird level of behavior. So if you take a look, actually, I've kind of drawn these out in a bit of a diagram. Maybe not the best diagram, I'm not that skilled, but as you can see, you've got your kind of simple reflex agents. These top five live within their own ecosystem. So they're agents that live within their own ecosystem. Now they can be called by other agents if you allow them to, but typically they're self-contained. So when you test them, you're only testing a single ecosystem. All right, so that should make sense. Okay. However, what about when you start thinking about your orchestration agent? So it's a single parent right now with multiple children, parents these days. But what happens is that if this agent changes at the very top level, so you can see if I go ahead and I actually go and edit the model in this agent over here, so you can see Claude's deprecating, it will start behaving differently because it has a collection of child agents. So what you may find is that this child agent called commercial contract starts behaving differently because I've changed the model in the primary, and then I may have to change the instructions. Now we're into a whole other world of agent lifecycle management, right? Because it's not that simple. If I change a comma or add a full stop, what happens to the agent? What happens to the activity? What happens to the agentic pathway that this agent goes down? So this is where things like your evaluations come into play, where it's really important for you to be able to go through the process of running evals against an entire set of agents, an entire agentic system, rather than just one. Okay, very key. So what happens to your testing? What happens to red teaming? And we will get into that at a later point. But this becomes increasingly difficult to manage because these instructions are free text. They're not like code. So when you write code, you can do a compile, you can check syntax, you can see how code is working together. You can't with this because it is free text. So ladies and gentlemen, well, back in the day when we are writing HTML code, not in this scenario, but when we were writing HTML code and like WordPad, publishing that up to IIS, Internet Information Services, and hoping to high heaven that the div tag was in the right place. Don't know about all of you, but I went through a lot of that. It was really weird in the beginning. Now we have compilers and all this other wonderful stuff. So yay. But now you got to start thinking about the impact, the change you make on the model and the instructions. So when I wheel back to this, there's a lot of people that are hammering loads of functionality into singular agent ecosystems because they think it's easier to manage, but actually you end up overloading the agent. So it'll take longer, it'll be less performant, and you're not actually building out into your agentic ecosystem. What this also means is we have to think about the governance and how you want to classify your agents. Okay. This will matter later because as you go through the process, again, not all agents are made equal. I'm sorry for you that I have a cause for digital agent equity, but it's not a real thing, right? So, yeah, you're going to have to figure something else out. But as an example, this is my innovation pipeline using agent types. So you can see I've got simple reflex agents all the way down to my agent mesh. Okay. Now, what will happen is when I go through the process, I always want to build me as Chris, say I'm not a dev, right? Like low criticality, low complexity type agents. So that's me build or somebody within my org. But as I really want to build out high impact use cases that are low complexity, high criticality. Okay. Now, these may not always be agent mesh because these are very difficult to manage. Okay. They're very difficult to govern and test. However, singular agent ecosystems that have very basic versions of utility or action are way more easy, simple to manage. These ones are going to replan, right? I'm going to start thinking about, hey, they're high criticality, they're very important to my business, but they're quite complex as well. So I need to plan that build. I need to go ahead and actually think about really how do I architect this, which we'll get into other sessions. And lastly, what we really want to rethink is like low complexity, low criticality. Okay, like what does that actually mean? If it's high complexity, low criticality. If it's highly complex and low critical, rethink it. Like, can you absorb it into another agentic system? Is there a better way to manage this? Okay, now, again, your innovation pipeline, you should be building your do now or you builds. Okay. You really want to plan these kind of highly complex, highly critical agents, but the real wins are in the do now brackets. Highly critical, low complexity. And that's typically where you're going to have your like kind of three core agentic types. As I said before, you may end up doing this with the category rather than the type. So also let's think about your kind of agentic governance, you considering complexity. Okay, so my agentic governance considering complexity, you can see I've got the purple zone, the red zone, the yellow zone, and the green zone, right? Lowest governance is always green because you're not writing back. There's no action on these agents. It's retrieval, so the governance is less. But the minute I am adding utility to this, I'm writing back. There's a little bit more complexity and governance required. Like as an example, Copilot Studio, you have a thing called actions, right? These actions are effectively leveraging connectors. Connectors are part of the Power Platform ecosystem. They write back to things, okay? So it's important to note that if I build an agent that posts to Twitter every 5 seconds, that's a dumb idea, all right? It's going to need a lot of governance. And as you move up, these agents become more and more complex to manage, okay? Now, this is one of the versions that I like. There are many other versions like this. As you can see, I've removed the colors, right? So I've moved away from just my banding across complexity to not considering complexity at all and thinking about how I would categorize these agents. So a lot of people say, hey, it might be like low complexity, but actually we don't really, the criticality is kind of irrelevant, right? Like we're just going to build out our retrieve and advise agents in there. Our collaborate agents and assist agents go into that category. And then your orchestrate and perform agents live in that category over there. Okay. So this is without considering complexity. Now, I struggle with this, and this is depending on the organization. A lot of orgs I talk to want to understand complexity. They want to govern it differently, and I like that, right? But some don't. Okay, so this is just an example. And then finally, again, the agent type considering complex without the complexity. Okay, so you can see I've actually only gone for 3 governance bands, left out the purple one because it's still high governance no matter what I do. But actually, I can have an agent mesh that is low governance because you know it's actually not that impactful. Again, not necessarily the right route. My favorite model is still the one that considers complexity. But yeah, what I want you to do is when you go through this process, start thinking about the types of things you want to be building. And I actually am going to be doing demos in the next few sessions showing you a lot of these agent types. But start thinking about the types of things you're wanting to build and start writing your ideas down. So think about the processes you have, think about the things that you're trying to solve, and actually write them down. Now, I always go for like processes that I hate doing. So if it's overly manual, I can't stand it, like expenses and timesheets. But think a little outside the box. And when I start lighting this up with technology, it'll give you a much better way to kind of understand, hey, based on how agents work, these are the types of problems I can solve. So we will get into that into the next sessions. But this one is specifically on agent types. So you get varying categorizations and types. I prefer the technical approach, but a lot of other folks don't. So if you want, there's a link in the chat. You can go and share your ideas. What will happen is those ideas will then land up on my very, very delightful website. So I will be able to go. You're going to land up on my website using this form QR code. I'll go in and check those ideas out, and hopefully I'll be able to help you out. So this is what the website form looks like. Obviously, it's a Microsoft form. There's Agentic AF, architectural framework. So you can go fill your idea in there. And if you want, I'll give it a review, depending on how many ideas I have and how much time I have, and I'll feedback. Okay. So thank you very much, everyone. I hope that's all made some sense. Next time, we're going to be looking at some of the epic tools that are available to us. And yeah, I'm looking forward to showing you some more stuff. So, with that, thank you all so much. And next time, let's do something even cooler than this. Rock and roll, friends, and hopefully see you soon. Ciao.